Today's topic is NARS as a unified model. I used this slide before, so you'll see, according to my summary, the strategy in the current research of AGI with respect to how to build an AGI system can be roughly classified into three major schools or groups. The first one, I call it hybrid. The basic idea will be to combine the existing AI technology together to get a general purpose system. The second approach is called, I call it integrated. That basic idea is to get some kind of architecture first, then to build individual components according to the overall design, then put them together to work. And finally, the third approach, I call it unified. The idea is basically to use one single technology to carry out all types of functions. Well, as usual, each of it has its strengths and weaknesses. Currently, there is no consensus. My own approach, as you know, is the last one, which is widely criticized as being too naive. The usual objection is, intelligence is such a complicated phenomena or process. There is basically no way to use a single technology to do it. On the other hand, it's better to use multiple technology so that they can support each other, they can supplement each other, and so on. It's make a lot of sense. But still, my approach, I don't agree with the other two, mostly because of the consistency issue. Even though it sounds good, when you actually put them together, you will see there are a lot of troubles to work together. On the other hand, if you start with a single technology, there is no such issue, or the issue become much smaller. But how to address the criticism saying that the single technology is too simple to address general intelligence in all aspects? That's what I try to answer you today's talk. So the technology itself, we have talked many times in this group, so I will just summarize them in this slide. First is kind of like the philosophical foundation, that is my working definition or understanding about intelligence as adaptation under insufficient knowledge and resources. Then is the technique itself. I use a reasoning system framework, but I developed a new logic, which is an extended version of the term logic tradition. I use a novel semantic theory, which I call experience grounded semantics. Then another caricature is truth value. I use two numbers to represent truth. Then the memory structure is what we call a concept-centered memory structure. So it's organized around a concept model. And finally is the inference control is not following a given algorithm. Instead, it's use dynamic resource allocation. So this is a very, very rough summary about what NARS is. Then before continue, I have several disclaimers to make, just because today's talk is very different from all the other talks. Because in the following, I'm going to touch many topics, and on each of them, I will basically only have the time to say one or two sentences, basically to explain how it is handled in NARS. I'm sure you will have a lot of questions and even objections about my treatment, but today we're not going to spend time on any of them because each of them will deserve a discussion of several hours for sure. Okay. So bear with me because here today the point I want to make is to justify this overall strategy of using one technology to do all of this. Another thing, I'm sure they will see that for many of the topic, my definition is different, more or less, from the widely accepted in the field. Okay. Again, I'm not going to discuss or justify my position today, but we can discuss that in the future if there is enough interest for each of them. Also, finally, I'm not claiming that NARS have provided a final answer for any of the topic. Okay. What I'm claiming is we have at least provide a preliminary solution to it. And of course, there's still a lot of work to do. Okay. That applies to everything I'm going to talk about in the following. So the first is actually I will start from semantics. This semantic theory, the basic idea is summarized here. A concept in NARS is a data structure identified by a term. The meaning of the term, or also you can talk about the meaning of a concept, which are more or less the same thing, is defined by its role in experience or by its relation with the other terms and concepts. That's about the meaning. And also truth. The truth of a statement corresponds to express and experience conceptual relationship. Okay, so it's not to compare a sentence with the fact, but with the system's experience. And this position, I will say, consistently answers several major theoretical debate in the field. One is a symbol grounding problem, which we discussed before. Okay. So I keep saying that NARS is not traditional symbolic AI because a term is not a symbol which need to be interpreted to get its meaning. That's where the symbol grounding problem comes from. Instead, a term just summarizes the system's experience. So it's already grounded. That's why this is called experience grounded semantics. No interpretation is needed, so the system knows what it means to itself because of where it comes from in the experience. Secondary, the meaning treatment in NARS is very different. Another aspect is meaning changes. The meaning of a concept and a term change over time, is experience based, and also is sensitive to the system's current context. So it answers the challenge raised by the so-called embodied cognition, situated cognition. I kind of like agree with both of them in spirit, even though not in all of their details. And also the concept is fluid using the term of Doug Hofstadter. So that's about meaning. And truth value in the system measures the evidential support of a statement. So a major motivation actually is to answer Hume's problem about induction. Okay. Inductive inference is based on experience in the past, but is extended to the future. So how can you guarantee the truthfulness? Well, if I actually redefine truth, there's agreement with experience. So there's no this problem anymore. In this sense, inductive reasoning and deductive reasoning can be justified in the same way, even though their differences are still there. Now, this is the picture also I have shown several times. That's what I call concept-centered representation. So everything is a term. A term is just an internal ID. Okay, you'll see in this picture, a term can correspond to a word or a phrase in natural language. And also it can directly correspond to a sensation or perception, like a mental image or something like that. And also it can directly name or correspond to a physical or mental operation of the system itself. And finally, it can be a pure internal identifier, which does not directly correspond to anything in the system's experience, but is indirectly related to them because of its relation with other terms. So to go into a little bit technical detail, in NARS, well, now most people in the group are familiar with it. There is a term hierarchy. What I just mentioned in the graph is more like the bottom level that is an atomic term, which is nothing but a string or an ID. And then on top of that, we can have compound term, which is formed from other terms using logical connectors like union, intersection, and so on. And then we recently introduced a special type of sensory term, which is basically a matrix correspond to multiple sensors, so that now we have additional information about their spatial arrangement or structure. And then we treat a statement as a special form of a compound term. So it's also formed from other terms. What makes a statement different is it has a truth value. So you can talk about whether it's true or to what degree it's true. And then an event is a special type of statement where the truth value actually is temporal. Okay, so it's true in a certain period and not necessarily true after that or before that. And then we have an operation, which is a special type of event. That's something that the system can actually carry out by itself, or it's an event that can be realized, can become true according to the decision or choice of the system. And then finally, we have a concept of a goal, which is also an event, which is the event the system desire or desire the system want to realize. So in this way, you'll see that the network I shown in the previous slide actually unifies several types of knowledge, which in most of other so-called ADI system or cognitive architecture, they typically use different memory to store and manage, like so-called declarative memory, episodic memory, or procedural knowledge. They're typically separate. And also definitional information here is actually in the structure of the compound term. In NARS, they're all together, even though I still acknowledge the difference between those types, as you can see in the term hierarchy. So those special type of terms are still handled differently, but they're all unified together in one single memory structure. So now we can switch to talk about concept again from to talk about its relation of this model with the traditional psychological model. You'll see that in psychology, especially in cognitive psychology, there have been a huge literature on how to model or represent a concept. The major approach, at least three of them, the prototype theory, exemplifier theory, and so-called theory theory. But the interesting thing is you see that actually they can all be handled or to be interpreted as a special case of the NARS model. Because you see, I said in the NARS model, the meaning of a concept is its relation. And here I further said it's not just you just call it relation, we further distinguish different types of relation, especially as those represented in NARS as inheritance. Okay, based on the inheritance relation, we define a concept of extension and intension of a concept, which intuitively represent a concept of specialization or instances and generalization or properties. So if you take that point of view, you will see that prototype theory basically focus on intention. So they define a concept by the common property or the property that a typical instance should have. On the other hand, exemplifier theory go to the other extreme, say that a concept is actually defined by its typical instances. Okay, you'll see that according to NARS, both are correct because both extension and intension matters. But on the other hand, I agree with this two theory. They can also find their evidence to support it, just because for some concept, intentional factor is more obvious or dominate the meaning, and for some other concepts, maybe it's extensional because of historical reason, how this concept is formed and so on. Okay, but in general, I disagree with both of them. I say this, both of them is just part of the story. Okay, so you should in general take both extension and intension into account, and without saying that which one come from which one. And finally, theory, they actually define a concept by its relation with other concepts, which is exactly what NARS said. And technically speaking, a relation, here, if we're talking about an object level relation, typically in NARS is represented as a special case or a special type of intention. Okay. So anyway, this kind of models can be interpreted by the NARS model as a special cases. And now, truth value. You'll see that for a typical inheritance statement, say there is an inheritance relation from S to P, and we use two numbers. The first number is called frequency, and the second number is called confidence. Frequency is the proportion of positive evidence among all evidence. Confidence is the proportion of currently available evidence among all evidence you're going to have, or the system is going to have in near future. Here, near future is defined by this system parameter K. So again, this one provide a unification of several type of uncertainty discussed in AI. For example, randomness. You'll see that if the previous statement is interpreted as there is a property P, which is some of the instance of S has the property P, and some of them does not have the property P. Then if we say that everything in S has a property P, clearly that's true only to a matter of degree, and that matter of degree is close to what we already call randomness. It's kind of like you pick a random instance of S, whether it has a property P or not, right? It is represented by a certain ratio or some number between 0 and 1. On the other hand, fuzziness, try to be captured by fuzzy logic is about something else. Where the fuzzy logic people have debate, argued for many years that fuzziness is not probability, which I agree, because fuzziness is more about the intention of a concept. Okay, the typical case is an instance S has some property of P, but not all of them. So we say whether S is a type of P is a matter of degree. Okay, so at the surface, of course, is different from randomness, which is more about extension. But you'll see that in my representation, these two are unified at a higher level. They're all different ways to collect evidence for a proposition. And actually, in many conclusions, these two will be mixed together after several steps of reasoning. And then ignorance is more about the second number, is about confidence. Ignorance typically represent I don't know, or I don't know much. Okay, so it's not more about whether it's positive or negative. It's about the total amount. And also inconsistency is about, for the same statement, you may have several different truth values coming from disjoint bodies of evidence. You see all of them appear in NARS, but they're captured with the same mechanism, same representation, handled by the same inference rules. Rather than use, for example, 4 different logic, each for each type of uncertainty. which you can see is here. There is already a huge literature on the so-called non-classical logic, okay? Because everyone, as soon as you do some research in this field, you know that classical logic is not enough. That's not something I propose. Already many people have argued for that for many years, okay? And there is tons of different systems developed, but each of them typically tries as one issue in classical logic. Okay? So you can see that NARS are actually similar to almost all of them in different aspects. For example, NARS clearly is a multi-valued logic. NARS is similar to probabilistic logic, as I just shown there. And also, sorry, I have some problem in my connection. I hope you can still hear me. The system is reconnecting. I will keep talking, okay. NARS is similar to fuzzy logic, as I mentioned, and also non-monotonic logic, like default logic and so on, developed in AI, which is typically address the issue of the system get new knowledge and use the new knowledge to change its behavior and previous beliefs. So its belief side will be non-monotonic because it can grow and shrink. Okay, the same thing happens to NARS because some of the previous beliefs will get frequency increase, and some of them will get the frequency decrease, and some of them even decrease a lot, so it becomes from change from positive to negative, which are all possible. And also to handle the existence of contradiction in logic, there is a school of logic or group of logic called paraconsistent logic, which basically means that even if you have a contradiction in the system, you should not, that contradiction should not implies every arbitrary conclusion. Okay? Instead, the impact of the contradiction should be somehow restricted to a certain small scope. Okay? And that issue is also handled in NARS. In NARS, you can have a contradiction which will cause trouble, but it will not cause a global trouble to that extent that everything else becomes possible. And also in my list is relevance logic, which was developed to handle implication paradox, okay? Meaning that from a false premise, you can derive anything, okay, which is related to paraconsistent logic. Okay? That issue is also handled in NARS. Actually, it's already handled in term logic traditionally, because term logic insists that all the premise and conclusion need to be semantically related. Okay, so it was not an issue there in the first place. Okay, hopefully now you can see my share screen. And inductive logic, induction was traditionally a big trouble in logic. There are several types of inductive logic developed. Okay, in NARS, you see NARS do induction. So in essence, you can say it's an inductive logic. But on the other hand, it's not inductive logic in the traditional sense because it does several types of logic reasoning. Okay, rather than just do induction. Also, on the right-hand side, there is a list of traditional logical issues or troubles or paradox. which NARS provide explanation to all of them, which I don't have the time to talk about. Actually, I have separate publications on each of them already. Okay, Warson's selection task just to say that in psychology, it's well known that people's selection in many problem-solving process does not follow propositional logic. Okay. Hamper's Raven's paradox basically show that again, people's intuitive judgment is inconsistent with if you want to introduce the concept of evidence into logical reasoning. Okay. And then Tversky, Kahneman's work, Ginninger's work on human bias and heuristics and adaptive toolbox, both shows, especially Tversky and Kahneman's work, human decision and judgment making does not follow probability logic. They basically say this is something wrong in the human mind. But in NARS, all those things in principle can be reproduced. So my argument is actually the problem is not in the human mind, is in probability theory, because that theory does not apply to situation where the system does not have the required knowledge and resource. Okay. So those errors are not necessary errors. There are still errors. I'm not saying there is no human error. But what they call errors or bias are not necessarily wrong. So this is a summary, a very brief summary about stochastic inference, which is the core inference rules of NARS. Okay, you'll see here the relationship is inheritance relation, and the dashed lines are premise, and solid lines are conclusion. Deduction comes from the transitivity of this relationship. Induction and abduction, on the other hand, also provide evidence for the conclusion, even though it's a weak inference because it cannot be very sure about the result, even if the premise themselves are pretty certain. And the revision, you can see intuitively as a way to merge conclusions into a stronger one. So in this way, actually, this pattern also does not come from me. Deduction, of course, that's from Aristotle's work and followed by the whole tradition of term logic. And then Aristotle mentioned induction, but he didn't develop any theory about it. It's later is C.S. Charles Peirce who developed this kind of like triangle shape by define abduction and induction as the deduction with conclusion and one of the premise switch. He said abduction and induction cannot provide sure answer, but it serves cognitive functionality because abduction provide explanation and induction provide generalization. So what happened in NARS is kind of like following Aristotle and Peirce, but extended from binary logic into multi-valued logic with experience-grounded semantics. Okay. Then this revision becomes. Can
you say a couple of things about the revision? I don't think everyone's familiar with that.
Revision is basically accumulation of evidence according to this experience-grounded semantics. Okay, you have some evidence from one place, you have some other evidence from another place, and then you pull them together, you get a new conclusion. So you just use the addition to add your evidence, positive and negative together. So it's kind of like you can call it belief revision that's also studied in the past. But typically, say like in Gardenforth's work, it's more mostly done in binary logic, which I think is not proper for this domain. Okay. If you use experience-grounded semantics, then this rule becomes pretty straightforward. You just add your positive and negative separately. That's basically it. And clearly the rule I just said is not all the rules. There are many other rules. Another bunch of rules in NARS is especially used to create new concepts. That's also different from the traditional idea where reasoning is to derive new conclusion, but the concepts remain the same, which is true in traditional stochastic. Okay, you kind of like draw new links among existing nodes. But in NARS, that's only part of the story. NARS can introduce new concepts in several different ways. One obvious way is, directly from the input. You can tell it's a new word which you never heard before, but it can be related to some existing concepts. So the new concept begin to get a meaning, which sounds trivial. But if you think about it, many existing current framework does not allow that kind of thing to happen. For example, Bayesian approach, many people does not realize that in Bayesian reasoning, all the reasonings must happen within a predetermined sample space or proposition space or event space, whatever you call it. Okay, you cannot introduce a new concept which was not there because there was no prior probability defined on it. Okay. In NARS, there is no such issue. Why? Well, it's not easy to extend the Bayesian network to do that. It's just because even though technically it sounds simple, it just add a new link and a new node in your Bayesian network. But the theoretical trouble is you cannot guarantee a new number is consistent with your existing probability distribution. Because so that will violate the axioms of probability theory. There is a danger of that. In NARS, we don't have such an issue because there is no requirement for consistency at that level. Okay. So if there is inconsistency, the system will handle it. That's it. So you'll see that's one type. The second type is the one that's shown in this diagram. That is, there is a bunch of inference rules which will is not traditional stochastic in the sense that it will not just build new links. It will actually create new nodes. Like in this example, if you already know this term T is in the extension of term P and Q, and this story already exists. And the system will automatically generate a PQ union and PQ intersection. The intuitive meaning is the same as in set theory. This idea actually comes from set theory. You can see clearly. But the extension in NARS is now it become multi-valued. What if the relationship is all a matter of degree, right? So what you can say about the conclusion. But I'm not going to talk about that. Instead, I will just show you that as soon as you have this kind of term, inference rules, in the reasoning process, the system will generate new concepts in the sense that it's a structure of existing one. Anyone who have tried to run NARS will have this experience. Sometimes it's not a pleasant experience because you will see the system will automatically generate a large number of concepts. Actually, many of them doesn't make much sense. The issue is, at the very beginning, actually, there is no way to know for sure whether a certain structure will become useful or not. Okay, so what NARS does at this level is kind of similar to evolutionary computation. It will produce a whole bunch of logically meaningful compounds, and then let them to compete for resource. And most of them will actually be eliminated, forgotten after a while. But some of them will be kept because they're useful to summarize some kind of pattern or structure in the system's experience. Like, for example, if you see that if the system keeps seeing that a lot of instances have shared the same, say, 3 property. Then in the long run, this 3 property will be bundled together, will be handled just as one single term, which provide a more economic way to organize the system's experience. That's where new concepts are useful. And finally, another thing that people,
just a random comment, when you reset your display, before you were recording and now you are not, I don't know if you want to be recording. It looks like
okay, sorry. Yeah, I do want to have this recorded. It's because some of them who are not here may want to.
Recording on my screen.
Really? Oh, wait. I was looking.
Yeah, it says it's recording, but I don't know. Clearly, it will miss part of it.
I'm confused because there's another icon on my screen that says record and it's gray. So sorry, I'm wrong.
Well, it is confusing. I'm not sure, but it seems to be recording.
Okay, so never mind.
Anyway,
sorry.
I cannot restart that because it's running.
Okay,
that hope is working.
Never mind, sorry.
But thanks for mentioning it. I think it's important to have it recorded. Anyway, there is a last tab that people tend to ignore, because to me that's also very important as a way to introduce new concept. That is, I already said the meaning of a concept in NARS is its relation, but there is a relation with other concepts changing more or less. Sometimes they actually change a lot if the environment change, if the system's experience change. To the extent that if you run for a long time, the same term may actually be related to something very different from the initial relationship, which actually means a new concept. It's just not like the previous 2 cases. This kind of new concept happened gradually. Okay, it's not just suddenly become a new concept. But I think this is important, and also I think we can find a lot of evidence to argue that the same happened in the human mind. So anyway, so now we say that's another thing I argued in my some publication. You see, learning. Until now, learning and reasoning are handled as 2 separate topics in AI, using different technology. The same is actually also true in cognitive psychology. But now you see in NARS, learning and reasoning is exactly the same process. There's 2 different perspectives of the same process. Okay? So we see that inference rules derive new conclusions, which is a form of learning. And also it creates a new concept that's a form of learning. And other than that, also it changes truth values. Of course, that's a form of learning. And also it adjusts the priority values distributions among the concepts and the tasks, which I will say more in the following. Roughly, it means that when you mention a concept, what relationship will be bring into consideration that change over time. Okay, because of resource restriction, you cannot really take all relationship or the full meaning of a concept into account. That's almost never possible. So this is about the knowledge or belief part, also what the system can do. That's what we typically call skill or operation. In the system, it not only form compound concepts, it can also form a compound operation as a special case. Because as I said before, operation is just a special form of term. Okay? So that currently we already have the ability to say, if A and B and C are operations, the system can form A, B, C as a sequence. So it's kind of like a macro operation or a small program. And even some statement can be conditional. Some statement can be executed as repeatedly or in a recursion. Okay, so in that sense, that we can use NARS to do some simple programming, and the system can learn skills from its experience by keeping the useful sequence of operations together and give it probably a new name so that just like in structured programming, right? We define simple operations and then build functions and functions or functions and function or function or function on top of that. Okay, it's the same story happening here. So that's clearly a form of learning. And finally, also unusual is in NARS, the goal and desire are also learned from experience. Of course, initially it's given by the user or designer, but then it will be learned by the system itself, which I will say a little bit more in the future, in next. And also another type of learning is active learning. So the system can also query the user or do some experiment by itself to get the desired knowledge. So you'll see that all this kind of thing happens, but very different from the current machine learning study. There is no learning algorithm in the conventional sense. On the other hand, it's nothing but this bunch of inference rules together with the control mechanism. But we can still talk about learning and reasoning as separate because reasoning is more focused on individual steps. Learning is more a focus on the overall effect or long-term consequence of some process. So these two concepts are still separate from each other. They're meaningful abstractions, but it doesn't mean they demand two separate implementation process. And this actually applies to many other things I'm going to talk about in NARS. That is, you can still use different concepts to describe the system, but it doesn't mean you have two separate modules for each of them in your implementation. That, I think, is a big topic in this unified versus integrated debate. Also, yeah, here is a little bit more details about reasoning. Even if we're talking about the reasoning, some simple NARS sentence can show you that we can actually cover different things as different type of what we call cognitive function or whatever. For example, perception. The simplest form, again, I'm not talking about all form of perception. The simplest form of perception in NARS is for a given sensory term, for example, a matrix of pixels. Ask the system, with a question mark before a concept, that means that's a variable to be instantiated. Okay, it's kind of like, what is this? And this means a certain pattern represented by a matrix. Ask the system to find out what is the proper concept to label that. Okay, that's the basic form of perception in NARS. And the reverse is a form of imagination. In the second line, you'll see I gave you a concept, say, give you a cat. Now in your mind, find a pattern, which kind of like provide the best example of this concept. That's what we call imagination. Prediction. In the simplest situation, you have a description about the current situation, then you ask it what will happen next. Okay. So here you see it's a temporal implication relation talking about what will happen after that, and this event is also a variable to be instantiated. Of course, again, this is the simplest form. Explanation is a symmetric pattern. That is, the current situation, you want to know what must have already happened in the past, which lead to the current situation. Okay, that's one form. Of course, there are many other forms of explanation, and this is one form. And the planning now is, in the simplest case, is looking for an operation, typically a compound operation, which when executed will lead to a certain goal situation. That's what we call planning in the simplest case. Decision making is when a statement is desired enough, it will be converted into a goal, then the system will actually pursue it. Okay. You'll see I mentioned at the end, many of them involve what we usually call causal reasoning. But as I explained before, there is no separate causal reasoning process in NARS. Instead, it's kind of like a cooperation of many of them and interpreted under a certain special situation. So you'll see I use this slide to show there are still different types of reasoning if you go into the detail. But on the other hand, everything which, as far as is not too simple, is normally or reasonably complicated, it will be a combination of those rules. It will be a cooperation to carry out a certain function. So this is also very different from some other cognitive architecture where you have, a box to say this is causal reasoning, another box, that box to say this is imagination. Then you draw a line between them, say, oh, they work together. Okay, that's a typical design in an integrated approach. Now NARS doesn't do it that way. And this is about a control mechanism. Again, it's a long story by itself, but I assume you're familiar with it. So here, the key difference is it does not follow task-specific algorithm. Instead, everything is solved by the cooperation of individual inference rules by dynamic resource allocation. So which rule will be used depend on the priority distribution, depend on the current available data and so on. What can be used to explain? For example, I have several things mentioned here. Remembering and forgetting. You see clearly in NARS, both is a matter of degree because it assumes the system cannot exhaustively search for something in memory. So some content will be more accessible than some other content. So say that to get something will be quicker than some other things that's relatively forgotten. Or some other things will be remembered better. Okay, so that's all explained. Also, the inspiration, which is very often taken to be something like a mystery or magic. In NARS, actually is something like you have a low priority thing happen to be selected for a certain task. From outside or to the system itself, it cannot really explain why this one is taken. It's kind of like magic. But according to resource allocation algorithm, that's, we know for sure why that thing is taken. And this kind of thing happened rarely, so we call it inspiration, okay, because it's not anticipated. Intuition is the other side. Inspiration is kind of like the uncertainty you see, you look forward. What will happen next? You say, I don't know. It will depend on my inspiration of which one will pop up. I will use that. Intuition is a look backward. You don't know where you come from. There are some conclusions where which is derived from many complicated reasoning process combined together. So at the end, if you ask the system to explain, it will have trouble. But this kind of trouble is not the same thing as like in deep learning, right? Here, it just you don't have a complete record of your process, even though each inference step itself is clearly explainable. You just don't have a complete history. If you do, and you will see, there is no such thing called intuition. Okay. Creativity, there's all kinds of creativity you can talk about. For example, I already talked about concepts and beliefs. When we say it's creative, it typically means that first it's derived by the system itself. It's not a given. It's not a derived observation. Second, we mean it's not derived according to a given routine. Okay, if you give it a routine, even though you didn't directly give the conclusion, then people will not call the result that's a creative result because the routine already decided what will happen. But for the system like NARS, the experience is in principle unpredictable. So some of the results we will call it creative when it's normal enough in the future. And also this is related to the unpredictability of the system. NARS to a large extent is unpredictable, not because it uses random number. Instead, it's because it's adaptive, so its behavior is determined by both its initial state and its lifelong experience, but not by either of the two alone. Okay, that's not, if you only know the design, you don't know what will happen next. It's just because experience matters. Functional autonomy, that's related to the goal issue. Okay, the derived goals generated by backward reasoning is very different from the traditional sub-goal in traditional AI. Traditional AI sub-goals just means to achieve the given ends. But in NARS, you'll see some derived goals have to be considered as the system's own because, as I said in the previous slide, is produced to a large extent by the system's unique experience. It's probably not anticipated by the designer or the user who provide the parent goal. Okay. And also, is related to originality because some of the goals may become even inconsistent with their parent goals in the long run. So you'll have to say, oh, that's an original idea. I told you to do A, but I didn't expect you say, okay, you eventually do D, even though if you follow the step of derivation, you will see D come from B, B come from C, C come from A, but not by deduction. Okay. And it's interesting to use this to explain something. For example, in the very simplest form, it can explain why the system can enjoy something which have no practical use. It's just like we enjoy art, okay, which may have no practical utility. So some perceptive process become preferred than some others. For example, NARS maybe after a while like circle better than triangle, and with no obvious reason. Okay, like means they will prefer that shape if everything else being the same, which is possible. At the other end, at the operation end, you will see that it's related to the concept of game or playing. That is, the system may prefer a certain kind of activity, which to us, we don't know why. It doesn't serve any clear purpose with respect to the other goals. So it's kind of like this action itself become a goal. But to me, you know, sometimes it's annoying, but to me it's inevitable given this kind of design. And now the system appearance in a new architecture, we have several channels. Okay. Sensors and actuators, you know, my philosophy is not to build them in the system, but to handle them as a plug-in. You can say they're organs or tools driven by operations. So NARS itself is neutral toward what kind of sensor it will have. It will have some sensor because otherwise it cannot interact with outside world. But it doesn't have to be something very similar to human sensors. And also, the system will have some internal sensors and actuators, which allow it to have some awareness and control to its own reasoning or internal activity. And this external and internal sensors and actuators actually are handled in the same way. There's nothing mystery, it's just there are different sensors and actuators. And both go through multi-level abstractions. This will apply to, for example, what is the emotion? Okay, the system's internal sensor will report the current situation and it will be summarized through several levels to get some category which applies to many different scenarios, but there is something in common. And finally, they will be combined into the overall experience. Here, I insert again the architecture of our new system. So you'll see here at the input, which can be anything you plug into it. Okay, it will go through several levels of abstraction and go into the overall experience buffer, which will eventually go into memory, and the reasoning happen here. And the result will also go through an internal experience buffer and merge with the overall experience. So eventually, the external and internal experience will be combined together, which will become the system's overall experience. The communication, some of the channel will handle not just directly work with, integrate with the physical world, but with other systems, which can be a human, can be another computer system. So in this way, it will handle natural language here. We haven't done that part yet, okay? But the plan is to handle it in the same way as how it learn other domain knowledge, rather than use a completely separate natural language processing module to do it. And also the system's understanding of a message, in this case, you'll see it will not only depend on the message itself, but it also depend on the system's belief, the current goal, as well as the context. That's why also a knowledge, natural language understanding is not handled as kind of like a standalone module, but is handled by the same reasoning and learning mechanism as used for other purposes. And this also explains the system's model of other minds, so-called. Okay. It will learn about its user and the other system and so on by learning how to interact with them and what kind of input will trigger what kind of output according to its experience and so on. And even though the system itself is non-axiomatic, it can have axiomatic subsystem, like, for example, it can use math, okay? It can use probability theory, it can use set theory, and so on. It will allow domain-specific representation. For example, for something we know that you don't want to use narcissist, which is not good. You rather use matrix or graph or some arithmetic expression and so on, or even special language. But in NARS, they're all consistently represented as terms. And their special truth value, also we can have binary truth for those subsystems, okay? But they will not be coded as F and C. Instead, they will be coded as a set category themselves. So being true or being false in number theory, okay? Or have a point as a probability in probability theory. They're all handled as concepts. Then inference rules in those systems will be handled as implication statements in NARS. So in the end, we can use NARS to emulate the inference in an arbitrary axiomatic system. So the NARS will become a meta system in that sense. Well, of course, it will not always do it very efficiently. Sometimes it can even get it wrong, just like us. Okay. Oh, finally, conclusion. What I want to show is I believe a major strength of NARS is it can cover a lot of things in a consistent manner rather than draw a block around each name and draw a line between them. Say, yeah, we are going to integrate that. NARS is influenced by many theories and technologies. I'm not claiming that everything I just said all come from my own research. Clearly, that's not the case. But I want to stress NARS is not a hybrid or integration of those theories. And finally, do not get me wrong, for application development, that's a different story, okay? For special application, I never believe to use NARS by itself is the better solution. Usually it's not. It's better to build a hybrid or integrated system, just handle that. But that's not ADI, that's a special application. And finally, I believe we can build a science of intelligence, or you call it cognition or mind or thinking, whatever, just like other science. That is with a common theoretical foundation. Okay, many people believe intelligence is a suitcase word. Okay, it will have to be a collection of a whole bunch of messy stuff. I never believe that. Okay, that's all. Thanks for